in our prescriptive code assembly, just to go over what this makeup is. So typically it's a sheetrock, which is commonly, what's considered a air barrier in most residential construction. But of course it's not all that consistent because we have electrical receptacles and lighting fixtures and things like that all mounted and penetrating it, and of course they're all open. The next part within this assembly would be our framing or cavity. Typically, again, in residential construction in North America is fiberglass. Fiberglass, as you know, like fiberglass, you can blow air right through fiberglass really, really easily. And so it is really prone to convection. So if we have warm air on this side from just in the nature of the heating of the house coming in through these leaks that are inevitably there, and then a potential for a lot of convection. So that's coming over and it's able to transport that moist air to the back of this exterior sheathing, which, as we learned, that warm air hitting a cold surface, water forms. And so that's where water is forming on the exterior, on the inside of that exterior sheathing. And so this is part of the prescriptive response to that. Instead of trying to address the building science and hear what sort of the root causes for it, they're prescribing a rigid insulation or continuous insulation on the exterior. Most commonly that's petroleum-based or very closed insulation or rigid insulation. And so that is effectively dropping that dew point. For the B-Public assembly, again, we have the same sheetrock is used on the inside in the electrical fixtures or J-boxes. The big difference is that all of that is on the inside of our air barrier. So our air barrier is continuous and uninterrupted, allowing a lot of flexibility for these interior finishes to happen without compromising the overall building performance or building science. Then moving to the inside, to the cavity side of that air barrier, we're using cellulose insulation, so it has quite a bit of a capacity for absorbing moisture. And then here coming to the exterior with our structural sheathing, again, it might be the same as we have over here, but because we've limited the amount of vapor that's able to come through it, we've got a lot less condensation here, and the big part is that it's vapor open, so it's able to dry from both sides of that vapor control layer.